All right. Welcome to today's session. Once again, you are going to get expert analysis of the WAEC Physics Practical question number 3. And just like before, I'm going to take you through a little theory so that you understand the main thing behind the practical you're supposed to perform. Now, in this experiment, you are provided with the following things. You are provided with a voltmeter, a milliammeter, a standard resistor that is labeled Rx, a rheostat, a cell, two different resistance wires labeled A and B, a micrometer screw gauge, a key, and connecting wires. I'm going to be showing you all of these things in a moment. So, you are given these things, and some people will be wondering, why do you have a micrometer screw gauge among the apparatus? So, like I said, I will explain the theory behind this so that you know what you really need to know for this experiment, or the things you are supposed to obtain in this experiment. So let me take you through the theory briefly. Okay, from our basic knowledge of Ohm's law, we know that V is equal to IR from our basic knowledge of Ohm's law. So in this case, you are provided with two different resistance wires. So you should have that V of A is equal to I of R A plus Rx. And this will be current IB. Then again you have, for the second one, V of B is equal to, I should have A here, I of B into R of B plus Rx. So, if you divide the first equation by the second equation, if you divide the first equation by the second equation, you should obtain something like this. VA all over VB is equal to IA all over IB into RA plus RX all over RB plus RX. Now, from this analysis, if we say that Y is equal to VA all over VB, and we say that X is equal to IA all over IB, then this is going to give us our slope. So this takes the form of a straight line equation, which is given as Y equal to mx, where you are plotting this on the vertical axis and you are plotting this on the horizontal axis. Don't forget, the voltmeter may not be connected across the two resistances. But in this case, we are assuming that the voltmeter is connected across the two resistances. So it will read both the resistance of the wire and that of the standard resistor. So from the slope of this graph, you notice that slope of the graph will be equal to RA plus RX all over RB plus Rx. Now, since the values of Rx are the same in the both situations, then you can obtain the ratio of the resistance of wire A to resistance of wire B from the slope of your graph. And for some people, for those who are wondering why we have a micrometer screw gauge, the micrometer screw gauge is going to be used to determine the diameter of the wire. And for every wire, the standard wire gauge depends on the diameter of the wire. So we can isolate the slope once again, and you know that resistance of the wire is inversely proportional to the cross-sectional area of the wire. Area in itself is actually equal to pi d all over 2 squared. So you find out that the ratio of the resistances of these two wires, like RA all over RB, should be equal to DB squared all over DA squared. This is what you are going to obtain from the slope of the graph. That is the ratio of the square of the diameters of those wires. That is why they have included the micrometer screw gauge in the experiment. So you plot a graph of the ratios of VA to VB as X against, as Y against the ratio of IA to IB as X. And from the slope of your graph, you can obtain the ratios of the diameters of the wires used. Like I said, the diameter of, the standard wire gauge of a wire is related to the diameter of the wire, even though the relationship is not linear. If you are interested in knowing the relationship between the standard wire gauge of a wire and the diameter, you can look it up on Google, or you can contact me using the number displayed on the screen, and I'm going to show you the equation that relates the standard wire gauge of a wire and the diameter. So let's go back to the experiment proper. So this is the circuit diagram that you need for this experiment. This is your battery, E, this is your key, this is your rheostat, this is the milliammeter, this is the standard resistor, and this is the length of the wire that is given. This is the length of the wire that is given, and the voltmeter is connected across these two. Although it is still possible to connect the voltmeter just across the given length of the wire provided. So look out for any of those two options. Okay, and the procedure is to use the screw gauge to measure and record the diameter D of the resistance wire A at three different positions. Determine the mean diameter D of A. Repeat this process to find the mean diameter D of the wire. This is done to check if the wire has a uniform cross section all through its length. That's why you have to take it for three different times. Then you set up the circuit as shown in the diagram above, with the resistance wire A connected in series with the standard resistor. So you now connect the voltmeter across both of them as shown in the diagram. Then the next step says adjust the rheostat such that its resistance is at minimum value. At that point, you close the key and read and record the initial current I0 on the milliammeter and V0 on the voltmeter. You will then adjust the rheostat to obtain 5 other readings of both current and voltage. Then you open the switch, disconnect wire A and connect the next wire B. Do the same thing. Obtain the initial readings I0 prime and V0 prime. Afterwards, you adjust the rheostat. Make sure that as you adjust the rheostat, you are maintaining exactly the same positions with which you took the readings for wire A. And afterwards, you evaluate Y to be equal to this and X to be equal to this. So I'm going to show you how a composite table will look like for this experiment. So let's go through. I have here the micrometer screw gauge. Your basic physics will teach you how to use the micrometer screw gauge. We're not going to do that here for want of time. You will use the screw gauge to measure the diameter of the wire at 3 different positions. Remember, the screw gauge can measure even the thickness of a piece of paper. So that's why it is recommended for this. You're supposed to have 2 wires. Here I have the rheostat. The rheostat is connected in this manner. You connect the red to the red terminal, and at the right hand here you connect to one of these, not at this point. So I've connected the rheostat to the key, and then from the rheostat I connected to the resistance wire here. This is the resistance wire here. to the resistance wire. The resistance wire in turn is connected to a standard resistor of Rx, which is 2 ohms. And then the voltmeter is connected across both of them. That's in parallel with both of them. Again, another interesting thing here is that what I have here is actually a center zero galvanometer. So one may be wondering, why am I using a galvanometer instead of using a milliammeter? Basic physics also teaches you how you can convert a galvanometer to either an ammeter or a voltmeter. So to connect a galvanometer to an ammeter, you connect or you set up a very small resistance with it in parallel. So I have done that with measured values. So this galvanometer as it stands can give a full scale reading of 100 milliamperes. Because I see some people scrambling and looking for milliammeters everywhere, and they don't know that they can easily construct a milliammeter using a galvanometer. So if you are interested in knowing how to do that in practice, you can still reach out to me, or you talk with me at the comment section, then I'll give you details of how this can be done. So I'll simply connect the battery. I'll connect the battery here. I have the battery at this point, and once I connect the battery, you notice that I don't know if the camera can capture the readings very well here. You notice that the milliammeter here reads gives you a reading, while the voltmeter also gives you a reading. These are the values that you should record as I0 and V0 for the first wire. I0 and V0 for the first wire. So I can adjust the rheostat. Then the readings here will change. The reading on the milliammeter changes, likewise the reading on the voltmeter. Then I can adjust and place this at 5 different points. You notice that each time I make adjustments, the readings are increasing. The readings are increasing as I make adjustments. You can see that. You can see that. So 5 different readings are taken apart from the initial readings. And after this, you replace this resistance wire with the second resistance wire. Ensure that it is 100 centimeters in each case. Ensure that it is 100 centimeters. Since both of the wires are Constantine wires, it means that their resistivity will be the same and their length will also be the same. So in that case, resistance now varies inversely as the square of the diameter. So that is just the trick. So I will show you a composite table that I made. A composite table that contains all the values that should be measured, their units, and where you are taking a ratio of the same unit, it shouldn't have a unit. So I'm going to show you what my own table looks like right now. Okay, so these are the values I obtained for my own practice. This is I0, which is the initial current reading for the first wire. I0 prime is the initial current reading for the second wire. V0 is the initial voltage reading for the first wire, and V0 prime is the initial voltage reading for the second wire. I have my serial number here. I have VA. Remember, you must maintain uniform number of decimal places in each column. So if you are using 3 decimal places, you should have 3 decimal places in everything. If you are using 2 decimal places for a particular column, you use 2 decimal places for that particular column. So this is what you should have. You plot a graph of a graph of Y against X. A graph of Y against X. You should get a straight line graph which may or may not pass through the origin, depending on how accurate your own values are. Remember I said from the slope you deduce the square of the ratios of the diameters of the wires used. Don't forget you're also going to record the diameters of the wires as DA and DB. And you are likely going to get questions from Ohm's law, why you have to unplug the key when you're not taking readings, and all of that. Then, the precautions you should state for this experiment, they are just typical. 1, you ensure tight connections when you are doing your experiment. 2, you take note of or you correct for zero error when using any of the meters like the micrometer, screw gauge, the milliamp meter, and the voltmeter. You correct for zero error when using any of these. You can also avoid parallax error when using any of these as well. Then you ensure that your key your key is open when you're not taking readings to avoid overheating the wires, because when the wires are overheated, remember, temperature affects resistance of the wire, and that will change the accuracy or will affect the accuracy of your results. So feel free to reach out to me using the numbers that are displaying or that is displayed on your screen. Reach out to me if you have any difficulty or if you need further clarifications on any part of this video that I've just put up. Once again, subscribe, like, and make comments, share, so that this video will go viral, so that many people will see the video and learn from it. Thank you very much.